Equilibrium. We've been discussing this for a few days now, and what factors affect the equilibrium? In class the other day, we were looking at one factor that could affect the equilibrium of that reaction. And we need to really look now at what factors can affect the equilibrium and how it actually goes about affecting the equilibrium. And these slides today will help you answer some of the questions and the reasons why your reactions did what it did today in class. So let's go. The outcome that we are addressing at the moment is this one here on the screen. Investigate the effects of temperature, concentration, volume and/or pressure on a system of equilibrium and explain how Le Chatelier's principle can be used to predict such effects. And then there's these three reactions here. So in class we looked at our cobalt chloride and we're adding a variety of things to that system and how heat would affect it. And we need to try and explain what's going on. So the first thing we really need to do is introduce Le Chatelier's principle. So different reactions will actually go to different extents depending on what's taking place in that reaction. So if I change that system at all, it's actually going to change what's happening in terms of the production of the reactants or the products, depending on which way that reaction is going. So if I actually add or remove a product, change the temperature or change the pressure, then we're changing the system that the chemical reaction's having to deal with. So Le Chatelier actually described these effects and it was coined Le Chatelier's principle. And what he actually said was that if we actually place a system under a stress, it will then behave in such a way as to try and compensate or counteract that imposed change. So for the one we are looking at in class today, it was the temperature and the effect that that has on equilibrium. So what I'd like you to be able to explain is if we change the temperature, either increase the temperature, such as heating it, or cooling it and putting it in ice, so therefore decreasing the temperature, what effect has that had on that reaction? And by being able to look at whether it's an exothermic reaction or an endothermic reaction, be able to predict what that would or what that result would be. So we do know already and have studied at some length exothermic and endothermic reactions. So when we've looked at these, we know that our exothermic gives off heat and our endothermic absorbs it. And again, going back to our delta H that we looked at in our last module, we know that a negative delta H is our exothermic reactions and a positive delta H is our endothermic. Knowing if our reaction is exothermic or endothermic will certainly help us decide or predict what will be the response to an increase or a decrease in temperature. So if I change that temperature, there's not going to be any change in the concentration of the products or the reactants, but one of those directions of the reaction is going to be favoured, and that will depend on whether it's exothermic or endothermic. So again, just to recap what Le Chatelier states, is if a system that's already in equilibrium has a change in conditions, so in this case it's our temperature, then the reaction is going to try and behave in such a way as to counteract that change. So looking at this reaction that we've got here, which is a reaction that you have seen before, this reaction is exothermic. So if we think of this, we really could put the energy as a product on the right hand side, but we wouldn't. But if we think of it as that way with the energy on the right hand side, if I increase the temperature, it's like increasing one of the products. So my reaction is going to try and compensate or counteract that change. So that's going to then drive my reaction to the left hand side, favouring the production of more of the reactants. So in this case then, we would get an increase in our NO2, and we would see that in terms of the reaction as a darker colour that we can see here on the left hand side in the picture. If I was to decrease that temperature now by putting it into a bowl of ice, for example, then what's happening is I am decreasing that temperature. So it's like decreasing one of the products, and the reaction's going to try and compensate by moving then in the forward direction or a shift to the right hand side, producing more of the N2O4. And again, that's our lighter color. So by doing that, it's trying to counteract the change that we have added. Now, one way we can describe what's actually going on in this reaction is described here in this slide. And that involves, again, our activation energy. So you can see in this diagram here that the activation energy for an exothermic reaction is much smaller than that for an endothermic reaction. So if I increase the temperature, we're not just increasing one side, we're actually increasing the system. So both the forward and the reverse reactions will increase. However, the endothermic will have the greatest increase in reaction rate. So the reaction will then move in that direction. So again here we can see these in our graphs that we're going to have a practice at drawing. You can see in the left-hand diagram, this is when our reaction is just going along in a normal system. You can see here that the concentration of one might decrease by a certain amount, and the other one, the NO2, is increasing by twofold of the initial. And that's again due to the mole ratio in the equation that we see. But in the second diagram here, you can see that the temperature has been increased. So on the graph here, we've got where our temperature is increased, and we can see here that we are having an increased production of the NO2, which is our reverse reaction, and a decrease in the production or being used up in that reverse reaction. Another example, and one that you did use in our class prac, was looking at our cobalt chloride. So our cobalt chloride in its standard form is blue, and our hydrated form is our pink. So what is actually taking place here? I want you to stop the camera and have a little bit of a think about how you would explain what's happening in this reaction. In this reaction, it also is an exothermic reaction. So we imagine as if the product on the right hand side is heat, and so an increase in that temperature is going to drive the reaction to the left or favour the production of the reactants. If I was to decrease the temperature, like in the previous one, a decrease in temperature is like decreasing one of our products, and it drives the reaction to the right or favours the production of the products. All of what we've just discussed can be summarised here in this table, where you can see an increase and decrease in temperature, what it does in the exothermic reaction, and what it'll do in the endothermic reaction. You can see two terms here that we are going to look at in a little bit more depth, which is our position of equilibrium and our equilibrium constant. You will also see in your prac that you did the other day, they are asking you to calculate the equilibrium constant, but we'll leave that for the moment and we will come back and address it at a later time. Thanks for watching.